All right, so 1.2 kind of goes along with 1.1. We're still dealing with transformations. The first part of 1.2, we're going to focus on translations and reflections. So we have this table here that shows us if something happens to our function, a certain type of transformation is going to happen. So looking at our first row of our table, we see if a number gets added to our function, that's going to be a vertical translation. So this means that it shifts up or down. So obviously if we're adding 2, we're shifting up 2. If we're subtracting 2, that means we go down 2. Next, if we have a number that's being added inside our parentheses of our function, that's a horizontal translation. However, a horizontal translation, we see that we have x minus h, so it's going to be x minus some number, so the sign flips. So it's always going to be the opposite of what you think it is. So if we have, let's say, plus 2, that means we move to the left 2. If it was x minus 2, we go to the right 2. So horizontal translation is left or right. And it's always the opposite of what you think it would be. A vertical stretch or compression. Compression's the same thing as saying shrink. So yesterday we dealt with a vertical shrink, so we'll just keep it consistent and say vertical shrink, but it means the same thing as compression. Remember, vertical stretch is when a number is being multiplied that is greater than 1. So if that number is being multiplied to our function and it's greater than 1, it's a vertical stretch. If that number is in between 0 and 1, it's a vertical shrink. So this is when it gets multiplied to our function. We're going to skip horizontal stretch and compression for now, so you guys can just cross out that whole row. And then lastly, we have a reflection. If x is being multiplied by a negative number, and that negative is outside the parentheses, it's a reflection on the x-axis. So if it's outside, it's a reflection on the x-axis. If it's inside, it's on the y-axis. I like to think of it as if you have like an ex-boyfriend or ex-girlfriend, you keep them outside your house. Bella laughed at my joke, thank you. Okay, so here's a little example on what each thing that happens to our function, on how it affects our function. So we see that if we have a negative on the outside, that means it's a reflection on the x-axis. Next, if we have a number that's being multiplied, it's a vertical stretch or compression, which compression is the same thing as saying shrink. If our function is being multiplied by a negative that's on the inside of our parentheses, it's a reflection on the y-axis. We're going to skip horizontal stretch or compression for now. If we have a number that is being added or subtracted on the inside, it moves left or right. And then if it's being added or subtracted on the outside, it goes up or down. And just remember, if it's on the inside, it's the opposite of what you would think. So let's look at some examples. So example 1, we need to state the transformation. So our first one is A. What family do you think this function belongs to? Quadratic. So we see this x squared, and it tells us that it is a quadratic graph. So we know our graph is going to be a U shape. But we have some transformations that occur to our graph. So first, we look at this 1/3. So 1/3 is being multiplied to our x, so that tells us that this is a vertical, either stretch or shrink. Since it's less than 1, it's a vertical shrink. And then just to be more specific, we can say a vertical shrink by a factor of 1/3. Next, we're going to look at this +7. So 7's being added, and it's outside any parentheses. So this tells us that we're going to go up 7. So we shift up 7. And that's it for A. Any questions on that one? All right, let's take a look at B. What type of graph do you think this is going to be? What family does this belong to?
Linear.
Linear. So since we just have an x all by itself, it's linear. Now we're going to take each number that we have in this function and see how it affects our graph. So first we have this negative out front. What happens to our graph? What transformation happens when we have a negative being multiplied?
Reflection over x-axis.
Perfect. Reflection over x-axis. Next we have this 2. What does the 2 tell us?
There's going to be a vertical stretch or shrink.
Which one? Vertical stretch or shrink?
Shrink.
Is 2 greater than 1?
Oh, so stretch.
Stretch. And then just to be more specific, we can say by a factor of 2. And then lastly, we're looking at this -1. So what happens to our graph when we subtract 1 from it?
It shifts down.
It shifts down. So it goes down 1 unit. Any questions on B? All right, let's look at C. What type of graph is this going to be? What family does it belong to?
Quadratic.
Quadratic. So this squared tells us that it is a quadratic. Okay, now we need to look at each thing that's happening in our graph, in our function. So the first thing we have is this negative in front of the x, so negative x. What does that do to our graph?
Reflection over y.
Perfect, reflection over y. Next we have this minus 5 on the inside. What does that do to our graph?
It's a vertical shrink.
Vertical stretch and vertical shrink only happen when something's being multiplied, but here we're subtracting 5.
It's a horizontal shift.
A horizontal shift in which direction?
To the right.
Right. So we're going right 5 units. Perfect. And then lastly, we have this plus 3 on the outside. So what does that tell us?
It's shifting up 3 units.
Perfect. Shift up 3 units. Any questions on this one?
Yeah. For the y-axis, if there's another negative, would it change anything?
Right, so if we had, let's say if we had a negative on the outside here, a negative on the outside means that it's a reflection over the x-axis, so we would just have 2 reflections. So first it would reflect over the x-axis, then it would reflect again over the y-axis. So that would be if we had 2 negatives. Was that what you were asking?
Yeah, it just cancels them.
It wouldn't necessarily cancel them because the negative on the outside would affect the 5 on the inside as well. So you just have to be careful with that, which I think we have an example on the next page that has 2 negatives, so we'll get to that. All right, let's take a look at D. What type of graph is this going to be?
Absolute value.
Perfect, absolute value. Okay, so now we look at each part. We have a 6 that's being added on the inside. What does this do to our graph?
It shifts to the left.
Perfect. Shifts left 6. And then we have this minus 10 on the outside, so how does that affect our graph?
It shifts down 10 units.
Perfect, down 10. So any questions from this page? All right, we have 2 more examples just like this on the next page. So let's look at E. What type of graph is this?
Quadratic.
Perfect. The squared tells us that it is a quadratic. What does this negative out front tell us?
It's a reflection over the x-axis.
Perfect. Reflection over the x-axis. Okay, next we have this 5 that's being multiplied out front. What does that do to our graph?
It's a vertical stretch.
Perfect. Vertical stretch. By a factor of 5. And then lastly, we have this 4 that's being added on the inside. So what does that do to our graph?
Shift to the left 4 units.
Perfect. So we shift left 4 units. So if we had a graph here, we know that our parent function of our quadratic is a U-shaped graph. So it would look like this. And we could graph this without even plugging in, we can graph this function without even plugging in any numbers. We know that the negative out front means that we reflect over the x-axis, so our graph now turns upside down. The vertical stretch by a factor of 5 means that our graph is going to be stretched really thin. And then next we shift it to the left 4. So we just go to the left 4. So our new graph would look like this. Now this isn't exact, but it's a good estimation of what this graph looks like. The green one. All right, let's move on to F. What type of graph is this going to be?
Absolute value.
Perfect, absolute value. Okay, now what transformations are happening? We start to the left. So what does this negative outside do to our graph?
It's a reflection over the x-axis.
Perfect, reflection over the x-axis. Next we have this 4. What does the 4 do to our graph?
We have a vertical stretch by a factor of 4.
Perfect, vertical stretch by a factor of 4. Okay, then next we have another negative sign. What does the negative on the inside do?
A reflection over the y-axis.
Perfect. Reflection over the y-axis. And then we have a plus 2 on the inside. What happens when we add 2 on the inside?
Shift left 2 units.
Perfect. Left 2 units. And then lastly, we have a minus 3 on the outside.
You shift down 3 units.
Awesome. Down 3 units. Any questions here? All right, let's move on to the second part here. So here we are translating and reflecting. So for example 2, we need to let g of x be the indicated transformation of f of x and write the rule for g of x. So we're given a function f of x, and g of x is going to be our new function that has this rule applied to it. So it's going to be f of x with a vertical translation 4 units up. So vertical translation 4 units up, this means we're going up 4. So we need to add 4 on the outside of our parentheses. We don't have any parentheses here, so we're just going to add 4 to our equation. So g of x is going to be 2x plus 3 plus 4. And now we can combine any like terms that we have. So we have this 3 plus 4 here. So our g of x is going to be 2x plus 7. For the second one, we have a reflection across the x-axis. Reflection across the x-axis happens when a negative is outside of our parentheses. Again, here we don't have any parentheses, so we can just put our negative out front of the x. So our g of x is going to be negative 2 times x plus 2. For C, our f of x is equal to 3x plus 1, and we're going 2 units to the right. So 2 units to the right means that we're adding 2 inside our parentheses. So we're changing x to be x plus 2. So our g of x is going to be 3 times x plus 2 plus 1. So we just replace the x that we have with our x plus 2. Oh, we're moving to the right, so this is going to be minus 2. So it's x minus 2. Come on, guys, you're supposed to catch me. All right, what do we do for D? We have a reflection across the x-axis.
G of x is going to equal negative x plus 2.
Perfect. So g of x is equal to negative x plus 2. So reflection across the x-axis happens when we have a negative on the outside of our parentheses, but we don't have any parentheses here, so we just put our negative out front. All right, so this was the first part of 1.2. Any?
I have a question.
Yes, what's your question?
For the last one, since it's reflection across x, doesn't 2 also have to turn negative? So you would have to put parentheses?
No, because we don't have parentheses around it to start. So if we were putting, all we're doing is replacing x with this negative x. So we replace x with a negative x plus 2. So this
Okay.
negative is only applying to this x.
Alright.
For today, guys, you don't have to turn in your notes. I know some of you already did, which don't worry about it if you did already, but don't worry about turning in your notes.